Hello, everyone. I hope you're doing well today. I can see from our chat box that we have participants from different places here and even from outside of the Philippines. For those who just arrived, please feel free to type in your name in the chat box where you're watching this webinar from, what company, university, or organization you're representing. Welcome, welcome. I hope you're having a great week so far. Again, good afternoon to all our participants. I am Emily from SuperMap, and I would like to acknowledge our host university, University of Southern Philippines Foundation. Say hi in our chat box, please, students and faculty of USPF. And to everyone here, it is my pleasure to welcome you to this webinar entitled SuperMap 2D and 3D GIS in the Real Estate Industry. To jumpstart our event for today, let us hear some opening remarks from the Dean of the College of Engineering and Architecture, Engineer Alfredo B. Arenajo.
Hi, good day to each and everyone. In behalf of our beloved Dean, Engineer Alfredo Arenajo of the College of Engineering and Architecture of the University of Southern Philippines Foundation, I am Engineer Michael Inso from Geodetic Engineering Department, welcoming you all to this webinar. This webinar will have a topic of the SuperMap. So SuperMap 2D and 3D application on the uh, real estate applications on real estate industries. So this topic will be a very informative topic to all the students and the participants of this webinar. So enjoy listening to our guest speakers. Once again, I am Engineer Michael Inso, welcoming you to this webinar. Thank you.
Thank you, Engineer Michael Inso, who is representing Dean Arenajo for us today. We would also like to hear from SuperMap, top GIS software provider in Asia and one of the largest GIS platform manufacturers in the world. Here is a message from Evelyn Sun, General Manager of SuperMap Asia and Oceania Center.
Okay, good afternoon, everyone. I'm Evelyn, the General Manager of SuperMap. So as always, it's such an honor to be in the presence of these professional students, enthusiasts, and all the other friends in the jazz industry. Even it's just in a virtual setting such as this one, I would like to thank the University of Southern Philippines Foundation for this collaboration and for allowing us to present our company, SuperMap, and our latest technology today. And it's my pleasure to welcome all of you to this webinar, which is titled SuperMap 2D and 3D GIS in the real estate industry. And part of the journey and the mission of our company is to share our solutions in different industries in the Philippines. I may not be able to see all of you in face by face, but I would like to recognize all the faculty, students, and other GIS practitioners, technologists, and innovators for joining us today virtually. With your interest and enthusiasm in technology and innovation, surely we can create sustainable solutions that would transform this world. The application and utilization of scientific innovations and technological solutions are just as equally important as its development. So our team in the Philippines has been working very hard to ensure that this information and demonstrations have a wide reach in the country. So I would like to thank you all in advance, ladies and gentlemen, because through your presence and participation in the webinar today, we can accelerate and mobilize our ideas and contribute to the progress of our society. I hope after all the presentations today, you will be interested in SuperMap technology and be encouraged to use and share the software with your company, with your colleagues and classmates and any others. And I'm confident that you will find new ideas with today's discussion. This is our third webinar in the Philippines, and I look forward to more in the future. So again, welcome all of you, and let us all learn and enjoy this fruitful webinar today. Thank you.
Thank you, Ms. Evelyn. Moving on to the topics for today's webinar, we are going to have two presentations. If you have any questions while listening to our speakers, please feel free to type it in the chat box below. The technical team will answer the questions in the Q&A session after the presentations. Our first topic is on SuperMap GIS technologies for 2D and 3D integration, to be presented by Marife Belando from the Business Development Team of SuperMap Asia and Oceania Center.
Good afternoon, everyone. I am Marife Belando, in charge of the business development of SuperMap in the Philippines. And today I'll be presenting about SuperMap GIS technologies for 2D and 3D integration. This is the outline for my presentation this afternoon. So first, I'll be introducing the SuperMap GIS technology and company. SuperMap was founded in 1997 by Dr. Ershun Zong, and with that, we now have about 24 years of experience in the GIS field. SuperMap is headquartered in Beijing with 38 branches and offices in mainland China, Hong Kong, and Japan. As of now, we have over 4,000 employees. And we are happy to announce that we have some job opportunities available for you. So should you be interested, just visit our Facebook page, facebook.com/supermapph, or just email me directly at marife@supermap.com. So this is the China GIS market share in 2015. We can see from this chart that SuperMap became the top one GIS software provider in China in 2015. Also in 2019, SuperMap was able to climb as the top one GIS software provider in Asia. Shown here is the SuperMap partnership map. As you can see, SuperMap has already been promoted in the market in South Korea, Indonesia, Malaysia, South Africa, and also some countries in Europe. And to date, SuperMap has about more than 700 partners from all over the world. Some of them you might already be familiar with, like IBM, Microsoft, Huawei, and others. And SuperMap has also entered the Philippine market, and our business is still expanding. So connect with us through the emails that you see on your screen. So this is the SuperMap products family. You can see here, SuperMap has 4 ranges of products from Cloud GIS Server, Edge GIS Server to different terminal GIS. And for different terminals, we provide PC, web, and mobile GIS. For PC GIS, we can use SuperMap iDesktop to do the data processing and then publish using SuperMap iServer to publish the data to the cloud. And then you can use the data published to develop different technology GIS. For the PC GIS, we provide SDKs like Java, .NET, C++, and etc. In the web GIS, we can provide JavaScript, Python, and others. So these are the 5 key technologies of SuperMap. We summarize them as BitDC. We have the Big Data GIS, the AI GIS, 3D GIS, Distributed GIS, and Cross-Platform GIS. We'll be focusing more with 3D technologies that is integrated with 2D. So SuperMap 3D GIS has gone through more than 10 years of development. Early as 2008 to 2010, SuperMap began to develop our own 3D products. And it was in 2009 when we proposed the integration of 2D and 3D technologies. We released the 2D plus 3D integrated platform software that same year. In 2015, one of our business partners applied GIS to the BIM industry in Shanghai Tower project and applied BIM plus GIS technology in the operation and management system. And through the years, we furthered the in-depth development of new 3D GIS technologies. As you can see here, the new 3D GIS applications is divided into four main parts, beginning with the 2D and 3D integration model, containing the several types of data models such as the 3D points, 2D network, TIM, TIN, voxel grid, and grid. The second part is the 2D and 3D integration technologies. So we are not only aiming to display 2D and 3D data separately, but integrating both of this data. And also, we're capable to consume different types of data like oblique photogrammetry data, BIM, point cloud, 3D field, and others. And after we import it in our software, we can give an output in various formats and iterations by using VR, AR, WebGL, and also 3D printing. So next, I will now discuss how SuperMap is able to integrate 2D and 3D data and what are the types of data that SuperMap can handle. So why integrate 2D with 3D? With 3D, we can address the various problems that cannot be solved by traditional 2D, such as multiple rules conflict, landscape discordance, problems with road profile, land subsidence, and urban drainage. To create the 3D digital space, SuperMap's 3D Designer extension provides the capability for 3D heterogeneous data integration from multiple sources, combined with built-in analysis and calculation functionalities, and at the same time visualizing real space in a rich 3D scene. Output from 3D Designer can be adapted to multiple technologies from components to terminals and also to the cloud. Using 2D and 3D data models, we can express the 3D real space and then generate and visualize it to its counterpart in the digital space. We can then use this digital twin as basis in making intelligent decisions and combine with the various spatial analysis and functionalities, we can then resolve the spatial conflicts generated from the 3D real space. Next, we're going to discuss what types of data models do we use in integrating 2D with 3D. So SuperMap is capable of handling different types of data models of 2D and 3D, from object models containing points, lines, and polygons to field models and visualizing continuous surfaces and 3D spaces. Thin and grid for surfaces and TIM and voxel grid for 3D. We can also generate network models both in 2D and 3D. From 2D objects, we can create the 3D model of our data when we load it to the spherical scene. Even after adopting the models into 3D, we maintain its integrity and effectively represent discrete objects. And not only the lines and polygons, we can express the 2D surfaces from thin and grid into 3D spaces with the use of TIM and voxel grid. Using these 3D field models, not only can we elevate surfaces to spaces, we can also do various spatial analyses. And we can do visibility analysis in determining the visible and invisible areas from a selected base point. We can also do shadow and solar analysis to show the model's shadow and the amount of sunlight for different times of the day. And we also have the skyline analysis and openness analysis to determine the free spaces around an area. So these are the multiple sources of 3D data that SuperMap supports. So this include but are not limited to terrain, oblique photogrammetry model, BIM, fine model, field data, pipeline, point clouds, water body, and geological body. We will be focusing on the first four mentioned data types. So first, we can integrate terrain data with other 3D data. Shown here is a 4.5 terabyte worth of terrain data. So with SuperMap's big data handling capabilities, rendering is as smooth as this one. This example will be very beneficial for developers of subdivision properties and housing projects. Another source of 3D data that SuperMap supports is Oblique photography model. So with the features of oblique photogrammetry models combined with the advantages of 2D GIS, SuperMap 3D GIS realized basic functions of 2D and 3D integration of oblique photogrammetry model, also providing multiple 3D spatial analysis functions. We have here the oblique photograph, its model in the 2D map, and the identified object in the 3D scene. Also, one of SuperMap's key technologies is the AI GIS. So using deep learning, if you want to extract buildings, we don't have to digitize them one by one. They will be extracted automatically and do dimension reduction to get the bottom polygons of the buildings. Like this one. So next, SuperMap can also load and integrate BIM data from various sources. So what really is BIM? BIM stands for Building Information Modeling. It takes the relevant information data of building engineering projects as the model basis. It records the geometric and attribute information of building components in detail and accurately, then presents it in the form of a 3D model. Now let's take a closer look on how BIM model is represented on GIS platform. So there are many BIM software, but the file formats are different. In order to break through the bottleneck of BIM data access to the GIS software platform, GIS software has developed data export plugins for BIM software such as Bentley, Autodesk Civil 3D, and Tekla. Meanwhile, it supports import of the interchange format, IFC, CTGML, and others. Some GIS software also has a deep strategic cooperation with BIM-related companies. So now it supports the direct opening of some related BIM data in the form of data sources. The close connection between BIM and GIS data is then achieved. So there are two ways of importing BIM data into GIS platform. One is using an export plugin, and two is natively reading the BIM data. GIS software uses export plugins and conversion tools to achieve a closed connection of geological and GIS data API, laying the foundation for geological and GIS integration applications. In natively reading BIM data, we need to make sure that we have a lossless effect while importing the data, and that after importing, the features of BIM are still fully preserved, such as the data structure storage form and also the expression effect. So this will provide a strong support for BIM application in GIS platform. These figures are some examples on importing many kinds of BIM data from different BIM design software. Another question raised when we are trying to integrate BIM and GIS together is, how do we carry massive BIM data? So there are some methods to optimize the performance on displaying massive BIM data. The first method is the levels of detail, or LOD technology, provided by the GIS platform. It determines the resource allocation of object rendering according to the position and importance of the nodes of the object model in the display environment, and reduces the details of non-important objects to achieve efficient rendering operation. Such as when the 3D scene is zoomed in, the model represents a very fine performance. But when the whole scene is viewed, the model only needs to be displayed is in a rough way, which maximizes the occupation of resources and improves the performance of the whole 3D scene. Now, what if the original data does not have any LOD? If the original data does not have LOD and the accuracy of the data is not too high, you can simply simplify the triangulation in SuperMap for components that are not important in the model. Let's see for this example, this building, it has dense triangulations. If we don't need all these triangulations and they unnecessarily increase the amount of data in the model, we can simplify these triangles and the data size will then be smaller. The third one, as shown in the figure, there are a large number of the same door objects in the building. The instantation rendering technology is used to save and draw only one object, which reduces the pressure on GPU and RAM and improves the performance of 3D scene. Let's take a look at one application of SuperMap. This project is for Shanghai Center. It is the second tallest building in the world and the tallest building in China. The implementation of the Shanghai Center project is extremely difficult because it was the first time that China built a skyscraper of more than 600 meters. So the building has a total height of 632 meters and 121 floors above ground, with the construction area of about 570,000 square meters and 143 elevators. This kind of skyscraper has various requirements in the management stage. For example, all the facilities and equipment must function reliably, and emergencies must be noticed at the first instance, and managing operations must be efficient and economical. With such demands, a super tall building like Shanghai Center will naturally come across various challenges during the management phase. First, there are many departments in the building management, such as security, property, and logistics. You can just imagine how difficult and complex it will be to monitor the whole building with so many different systems. Moreover, in the operation process, the amount of data generated will multiply rapidly, and the analysis will increase dramatically as well. So this will require more people to do the work, but even with the great number of people working on the system and data management, because of the increased difficulty and complexity, some concerns won't be addressed still. So we'll leave those problems which people cannot solve to computers. In this case, we use BIM to assist operation and management. What I have to highlight here is that the total data size of the BIM model in Shanghai Center is about 252 gigabyte, and the number of 3D models is more than 3 million. Pretty impressive, but overwhelming, right? With such a huge amount of data, let's take a look at the results of its integration with GIS. So in this operating platform, floor queries can be made and we can choose different model systems in that floor. We have here water supply, heating, and security systems. In each system, we can click to view the KPI information of independent devices or search and locate them. And the platform is equipped with emergency management as well. In here, we can perform evacuation simulations like for fire emergency. At the same time, the platform can show the working conditions of emergency equipment. In the equipment management in the platform, we can set up a maintenance cycle so that we can immediately find the equipment that needs repair. The platform also has a lot of other management functions such as asset management, security management, and space management. GIS platform also provides a variety of BIM lightweight and triangulation network operations, including extracting shell, triangulation network simplification, sub-object simplification, deleting repeated vertex, computing normals, model splitting, model merging, and many other practical functions. So these two projects are examples of implementing BIM lightweight operations. There are various functions that we can do in working with BIM in GIS. The first one, we can perform editing of the imported BIM model. For example, we can move a sub-object of the BIM model into different location using the model offset. And also, we can edit the texture of the BIM model inside the GIS platform. Another capability inside the GIS platform, the users can check the BIM model information for each object to see the attributes of the properties inside the BIM models. Next, BIM models can also be grouped for better organizations. You can see on this figure, on the layer management, the BIM models are being grouped into different sections. With SuperMap, we can do dimension reductions from 3D to 2D. We can get the side and bottom profiles of the models of the whole map or for specific buildings. Aside from easily accessing the sections of a building, we can reduce each section to its 2D floor plan. With the continuous accumulation of large-scale 3D data, the integration and matching of multiple source data becomes particularly important. In this figure, it shows that BIM can be integrated with 3D thin data, photographic data, water surface data, and video data. This next figure is a CIM platform based on BIM plus GIS engine. You can see here the BIM model is overlaid with many kinds of data format and also base map. Inside this platform, we can perform some analytic functions. Lastly, another source of 3D data that is supported by SuperMap and can be integrated with other data are fine models. So aside from loading BIM data for the buildings and other solids, we can easily build models inside the SuperMap platform. SuperMap provides sample textures, but you can also create and load your own textures to customize how your model will look like. In this next video, the model data is over 500 square kilometers. So you can see here, SuperMap can load it smoothly and quickly without any buffer. In addition to supporting and generating various data models, we also implemented a distributed processing solution for terrain, image, and 3D field data. Based on distributed technology, we have achieved efficient full process management capabilities for 3D data from data access, data processing, to service publishing, and multi-terminal applications. After discussing how SuperMap integrates 2D and 3D data in the various data models and sources that we can integrate to create the 3D digital space, I'm now going to show you how SuperMap is able to improve the various ways that we can interact with 3D. With the continuous progress of large-scale 3D spatial data collecting technologies, 3D spatial data formats are also increasing, such as 3D tile on the Cesium platform, OSGB on the OpenScene Graph platform, and 3MX on the Bentley platform. The majority of users should have a deep understanding of the inconvenience of conversion between different formats and different versions on different platforms. Therefore, the efficient 3D spatial data release, sharing, and interoperation in the industry has always been an issue for the entire geographic information industry. Faced with these problems, a unified and open 3D data format is greatly needed in the industry. The open and extensible 3D geospatial data format, Spatial 3D Model or S3M, can provide specifications for the data format for the transmission, exchange, and sharing of spatial 3D model data between different terminals. S3M solves the problem of multiple source heterogeneous data and provides standardized data format and can be adapted to various forms of user applications such as virtual reality, augmented reality, PC, web, and mobile. So SuperMap provide a free S3M data file reading and writing software development kit and provide development tool examples such as documentations and data. We also provide free data format conversion tools. This shows how 3D in S3M can be expressed and adapted to different terminals. So with the creation of iClient 3D for WebGL, there have been large improvements in three aspects. So first is high realism. We have done a lot of work for realism and special effects of 3D scenes and provided a lot of cool special effects while maintaining full functionalities and capability of handling big data. So many special effects have been added, including custom light source, 3D special effects such as dynamic texture and self-illumination, and OIT transparent rendering. And these various 3D effects can also be combined. Here are the particle effects in SuperMap. You can see here the fireworks, the fire. We have fountain and smoke. So these are all readily available. With the support of Unity 3D Special Effects export plugin, we can make more complex special effects. So let's take a look at this light effect. If you want to show how the models will look like at night, you can use this. So aside from improving the visualization of our 3D models, we can still utilize the various functions and spatial analysis tools. So that is visibility analysis. Here, we can access the underground to see the underground pipelines. This is the skyline analysis. We can get the skyline of the buildings. So in the visibility analysis, the green part means you can see them from the viewpoint, and the red part are the invisible parts. If you want to set one monitoring camera in one building, then pick the base position, you can use this analysis. And in accessing the underground pipelines, we can see the surface building and the underground pipeline at the same time in the same platform. We have also combined 3D GIS with augmented reality. We can move one building model on top of the desk. So this is the SuperMap building in Chengdu. With this model, we can do some 3D analysis, like the visibility analysis. Also with the AR technology, we can use the Mon body to control these models. You can get the sections of these buildings from the side and from the top. We can zoom in the model and even rotate it. We can also get inside the building to view the pipelines and check their information. We also combine 3D GIS with game engines such as Unreal and Unity. So 3D GIS will give the game capability for large-scale 3D data management and GIS analysis functions. On the other hand, using game engine gives better rendering effect to 3D GIS. The figures show SuperMap integrated with Unreal Engine. And this one is for Unity. In BIM, sectioning is an important feature, especially for the BIM indoor applications. In response to this demand, we also provide various sectioning functions such as cross vertical and horizontal section. So all in all, these are the functions that can be utilized with these technologies. So to end this presentation, I'll be showing you the incredible functions and output achieved with SuperMap with this video. So first, let's take a look at some of the application cases that SuperMap has achieved with 3D. So this is the urban management system in Beijing. And the urban planning in Zhejiang. We also have wetland management for Jiangsu and Hoyang Lake. With SuperMap, we can do a virtual exhibition such as the one for Beijing International Convention Center. So another is the real estate management in Jiangsu, showing the indoor model. Lastly, we have the facility management, university management, and emergency management for Beijing Capital International Airport. And the 3D special effects, which was also shown previously. So we can easily create models using symbols such as for markers, line symbols, and water surface. We can also have various 3D analysis such as the visibility analysis, measuring of heights and distances, shadow analysis, and we can interact with 3D using different terminals such as tablet and our phones. So I hope you learned a lot today. That's all for my presentation. Thank you all for your attention.
Thank you, Marife. Pretty cool, right? That was just a sneak peek of the applications that can be done with the 2D and 3D integration of SuperMap. While you're letting that sink in, maybe you can also start asking, how can this kind of technology be utilized in my field or industry? We're excited to hear about what you come up with, and we're very much open to collaborating with you to make that happen. Again, if you have questions about what Marifa just presented, anything about the BitDC technology of SuperMap or its 2D and 3D integration, please head to the Q&A chat box below and our technical team will answer them. Before I proceed to the next speaker, I would like to invite the students present here to join SuperMap's first ever local GIS contest in the country, Tagisan. You form a group of 2 to 4 members and pick a category or more in which you will showcase your GIS skills. More on that on our Facebook page, SuperMap Philippines. For our second and last topic, Ian Almazan from the technical team of SuperMap Asia and Oceania Center will be presenting to us the SuperMap solutions for the real estate industry.
So, good afternoon. I'm Ian Almadan, part of the technical team for SuperMap. So, we'll be presenting the SuperMap solution for the real estate industry. So, a background for this presentation will discuss a background of the real estate industry, how GIS helps in the industry, show cases of the application of SuperMap in the real estate industry of other countries, a discussion of the real estate GIS system, and lastly, a demonstration of the SuperMap functions for the industry. Okay, so why do we want to discuss a solution for the real estate industry? This may be interesting for several reasons. For as we all know, the real estate development for the real estate industry is increasing. Development takes place in almost every urban area. However, as more and more people want the real estate development, the land available for the development itself is becoming more scarce. As a result, the value of property has increased year by year because the land use is already very limited. Therefore, the community must optimize the use of land, not only in the horizontal direction, but also in the vertical direction. So how can GIS help manage this? I will discuss 3 aspects of the approach. So approaches from the users, the developers, and the governments. Then we will discuss how GIS can help in 2-dimensional and 3-dimensional approaches. So the first thing we are going to talk about is location intelligence. This solution is closely related to 2-dimensional data. In location intelligence, all data and geospatial data analysis will be collected to obtain strategic insight to solve the existing problem in the actual industrial situation. This solution can also be applied to the real estate industry. Before we discuss what features to use and the details of the analysis, let's discuss the internal and external factors that affect today's real estate industry and what opportunities exist. Each country has the same problems: uneven distribution of population, uneven economic growth among regions, limited market analysis data, tight competition among competitors, and so on. Very important for developers to develop buildings in the most strategic areas. So how do they determine which areas are strategic and which areas are not based on market data? This is where GIS works. At the time, let's look at the buyer side. So when buyers decide on the most strategic location, they will need external information such as how far away the area is from public facilities, or how is the traffic congestion in the area. This also can create a buyer behavior pattern that can be further analyzed. It is also inseparable from budget constraints of each buyer. So, elaborating even more, why is location important in this industry? Using information, you can find a place, areas, and locate their competitor. You will targets, you find easy access to go to. These aspects can be achieved by using location. And how do we implement intelligence to the real estate industry? So we can use this workflow. So the workflow is divided into 4 parts: collection, processing, visualization, and analysis. So in the process of data collection, external and internal data will be collected, and then the data will be cleaned and standardized to form the relationship between the data. The data is then displayed as name, for example, to show strategic locations, customer profile, and so on. Later, we will further analyze the relevant data, such as the area potential, the level of population density, and other insights you would like to know. So here we've listed some data that may affect the determination of the best location or area for real estate development. So the data is divided into 3 categories: the external data library, internal database, and mobile data. So after data processing, it can be visualized as needed. As an example, in this figure, you can see that we are displaying multiple layers: the administrative boundary, some POI, gender statistics of the area, thematic maps, which depending on the user needs, and some custom maps. You can also view user profiles or map internal data or competitor location on the map using a web application. So here we come to an analysis that can be performed using the data. We've only listed some features. One of them is spatial density analysis. In this analysis, you can create a surface showing the predicted distribution of population throughout the landscape. Therefore, the developers can manage to predict what is the best area to develop, something based on the predicted density. For example, the farther away from the target, the farther the customer will need to travel. Next, we have profile analysis. We can draw customer profile based on mobile data. In this case, we need to consider some factors about mobile data, such as the total number of devices we see, the types of gadgets they use, the network operator, data they use, and signal strength in the whole region. This will help developers to further predict, such as whether the area is suitable for high-end real estate development or medium-sized real estate development. The next analysis is site selection. So as you can see in the figure, the site selection is based on grid analysis. We use some parameters that can affect the site location process, such as location and distance of the considered points, and then grid analysis, which will change dynamically according to the set parameters. So after we do some analysis, we can also generate reports. For ordinary users who are not well versed in GIS, these reports are more comprehensive and easier to understand. So this will be of great help for the sharing and implementation of the summary. So moving on to the next part. So how can GIS help manage the real estate industry? The next part is interactive 2D and 3D output. In this case, we mainly discuss the cadastral system of high-rise buildings, or as we call it, the 3D cadastral. Why 3D cadastral? Because during the last 2 centuries, population density has increased considerably, making land use more scarce. This trend has impact on the increasing need for housing. Humans also adapt by carrying out building developments, both up and down, not only for housing, but also for infrastructure. So there is a saying in most land administration systems today are not adequate to cope with the increasing complex range of rights, restrictions, and responsibilities in relation to land. Existing cadasters, which are still based on the 2D paradigm, will need to be reconsidered and adjusted for today's world. In order to do this, an answer must emerge for the questions regarding 3D-based information systems, 3D-based fiscal determination, and 3D-based geometric description. So the workflow for this is data management, digitization process, 3D modeling, visual display, and analysis. So we will discuss this in the following slides. The first part of the flow is data management. In data management, it is mainly divided into business data management and spatial data management. So we all know that in the current industry, the existing data we have may still be traditional data or paper maps, which are not digital. These are land management data and real estate management data. It is being collected in the cadastral history database. Using this concept, we will create a digital system to update the data into a new cadastral database. So for spatial data, SuperMap supports various types of data which can be divided into file engines, database engines, and web engines. For file engines, we support vector data types and raster data types, 2D and even 3D data. For database engines, we support mainstream databases such as an SQL Server, Oracle, and others. We also support open network engines such as Google Maps, OpenStreetMap, which can work like base maps. This would be very useful if we had a rich data format, so the information process would be easier. This is a detailed format of spatial data that we support for the vector data, image data, and model data. The next step is digitization. So as mentioned earlier, the existing data may be traditional. So this is the process that will convert traditional data into digital data. So there may be two different inputs in this process. So the image data or the scanned maps and CAD data. We will try to convert these types of data into digital and standard data, or in this case, vector data using the 3D cadastral plugin of SuperMap. This is a customized module 3D cadastral plugin developed by SuperMap according to the user's needs. The purpose of the plugin is to create a digital standardized data for 3D cadastral model based on the input of image data and external table data. In addition, the output will be a 3D model data, which can be composed of each feature of the building itself. I'll list some of the features of this custom module as you'll see more details in the next demo after this presentation. As we all know, developers may have many floor plan data images In this tool, you can import images in batches to manage time more effectively. And you can set the information of each image, such as the parcel number and of the floor plan that is applicable to, which building it is in, and others. We also have an efficient digitizing process. We can start drawing architectural objects by clicking tools such as rooms, doors, cabinets, walls, roof, borders, and others. We can also set the floor name before drawing a feature to record which floor the feature is on. After that, we also have effective data conversion tools. So for example, in this tool, we can easily convert CAD data into vector data, as you can see. Then we go on to the 3D modeling part of the workflow. After digitizing the data into vector data, it can then be dynamically displayed as a 3D model by defining the height and floor name. You can also filter the display on each floor or even each feature. So it can not only be displayed as model extrusion data, but it can also be combined with oblique photogrammetry data to realize the real display of scene overview. So when it comes to integration, you may ask a question, how to solve the unified management of multi-source data? Because we know that there are many different standards or formats for 3D data. The release of Spatial 3D Model Data Format, or S3M, and Spatial 3D Model Data Service interface standard thoroughly opens up the entire process of multi-source data integration from data layer, service publish, service standard to service access. In SuperMap, oblique photogrammetry model data and 3D terrain data are integrated. Oblique photography model data provides polygon model of buildings in the real world, and terrain data provides the position information of oblique photography model data in the macro environment. Through the integration of multi-source information, it provides users with a more real and accurate visual experience, as well as the support from 3D spatial analysis data. Moreover, with the continuous development of technology, the monitoring service and cameras are in every corner of the city. And these cameras generate a large number of real-time monitoring videos every day, which contains rich information. In SuperMap, video data and oblique photogrammetry model data are integrated so as to utilize massive video information effectively and realize real-time information update of monitoring areas. So, through 3D symbol technology, spatial elements, these are the classic points, lines, and polygons, are rapidly constructed and visually expressed in the 3D scenes, which achieve real reproduction for these three types of elements in 3D scenes and effectively increase the utilization rate of basic surveying data. And it also reduces the modeling cost of the 3D data. This is a visual scene of 3D symbols. You can see in this picture, it is a 3D Max data visualization of the city. But in some places, it is displayed using 3D symbols. The ones displayed using 3D symbols are the streets, the lights, the roads, the water surface, and the trees. This is a dynamic visualization of 3D symbols or the 3D city. We use real-time reflection, dynamic water waves, and beautiful realistic effects from our 3D symbol library. So now we will discuss the visualization part of the workflow process. For service publishing and sharing of multi-source 3D spatial data, SuperMap is the first who proposes a 3D geospatial tile specification, the Spatial 3D Model or S3M in China, which solves the issue about inefficient transmission of massive and multi-source 3D spatial data in network and offline environment and visualization in multiple terminals. The technology promotes the construction process of Chinese 3D data asset security, control, openness, and sharing greatly. SuperMap not only proposes the S3M, but also forms a complete web application solution based on the specification, which solves the user's practical problems from data generation, server publishing, and various client loading applications. SuperMap adopts advanced HTML5, WebGL, and designs, no client 3D technology, and develops corresponding products like SuperMap iClient 3D for WebGL. SuperMap iClient 3D for WebGL is a lightweight 3D client development platform. It supports cross-platform and diverse browsers and accelerated 3D hardware rendering technology, avoiding from 3D rendering dependence on a plugin. Users don't need to download and install the plugin. They can efficiently browse 3D services. The technology improves the user's experience on web development and access. The accelerated hardware render provided by WebGL can display smooth 3D scenes and models in the browser. With help of system graphics card and web developers can easily realize the Web 3D effect on the browser using WebGL technology. SuperMap iClient 3D for WebGL adopts the Unified 3D Mapping Technology Standard, HTML5 WebGL, which enables it to overcome the limitation of operating systems, device terminals, and browser types. SuperMap iClient 3D for WebGL is suitable for Windows, Linux, Mac OS, iOS, Android systems, and it supports Internet Explorer, Chrome, Firefox, and other browsers. It runs on PC, notebook, tablet, and mobile phone device terminals. As a lightweight 3D client, users can realize web development and terminal access experience without downloading and installing plugins. At present, SuperMap has connected the functional bonds between web and server and docked within the server, expanding the analysis function of SuperMap iClient 3D for WebGL. SuperMap comprehensively supports 4 modules, functional capabilities, spatial operations, spatial query, spatial analysis, and rule modeling, which is convenient for users to build web applications. SuperMap iClient 3D for WebGL provides practical 3D measurement and 3D spatial analysis functions, including distance measurement and area measurement, sunshine analysis, profile analysis, contour analysis, slope analysis, flood analysis, visibility analysis, viewshed analysis, skyline analysis, and other expected 3D spatial analysis functions. So You can see in this figure that we support multi-type mobile terminal displays for 3D data. The last part is the analysis part. You can use 3D model data for a variety of analysis. If we talk about 3D cadastral, a kind of analysis mainly based on rules. The first analysis can be information query, which can integrate 3D cadastral model and oblique model data to realize the digital twin of real-world model and carry out query analysis such as query unit, unit plan, unit owner information, and others. Height control analysis can also be performed. The government has zoning regulations to regulate maximum heights of buildings depending on the zoning areas. We can perform this analysis to check if a building meets the rules. Legal distance detection can also be performed in 3D designer rules. For example, if a building is to be developed near a road, it will have a limitation of legal distance. You can use this analysis to detect whether the building has entered the limit of maximum legal distance or not, based on the distance of the road. You can also perform many types of 3D spatial analysis, such as visual analysis, shadow analysis, and open analysis. Basically, with this analysis, you will analyze which part of the area you can see from a certain viewpoint. You can also see the openness of your area, and you can also decide whether you can build high-rise buildings in an area. Okay, so now we will show you cases of the application in other places. So the first 3D figure is in Finland, where you can see that the real-world model is represented by oblique photogrammetry data in the web application. It can be said that for large-scale 3D oblique photogrammetry data, the rendering is very smooth. It is the same for the Netherlands case of 3D, but in this case, you may see that the cities are represented using other types of model data, as well as the trees, the street lights, and other 3D symbols. You can see we can also manage the 3D layers in this web application. This is an example of 3D cadastral implementation in China. We can see that we can combine 3D cadastral model data with oblique photogrammetry data, query and analyze the data, and visualize thematic 3D maps with colors for each unit parameter. So another way to visualize 3D oblique photography data in the web application. It is the smart city application in China. You can also query each building to see its properties. Interestingly, we all know that oblique photogrammetry data is a continuous surface, and by default, we cannot query each feature from the data. However, due to the available multi-type data integration, the photogrammetric data itself can be a query monomer for each feature. So this will be the last case that we will show you. About the real estate GIS system, the housing data can be managed both on the map and the TDC. So first, the 2D and 3D integration. Floors and rooms can be stored on a dataset. based on the floors and the rooms, 3D buildings can be created quickly. However, another modeling way is faster. Based on the plane graph and the height, a great number of buildings can be generated at the same time. So second, the data management. The spatial and attribute data of the floors and the rooms can be managed in an integrated way. The management of those data will depend on formations. Third, the unique identifier. Every block, building, and room will be given a unique ID. So fourth is query and analysis. You can input keywords to query the buildings that you would want on the map and view detailed information. So you can make thematic maps. For example, here, different colors represent different purposes for the buildings. You can also specify an area to calculate the number of buildings. And the data on the map may be displayed using pie charts, bar charts, or line charts. So now we will go to the 3D scene. Both the map and the 3D scene can be positioned in the same place. And here you can click the 3D building to see detailed information. So the fifth is the public WebGIS services. Through the internet, you can easily locate the house you're interested with in the map and find out information regarding transportation, education, or even entertainment near the house. So based on those factors, it will help you decide if you would want to buy the house or not. Sixth is indoor 3D viewing. So if you find a house that is located in a place that you like, you may go inside to see the inner layout of the house in a 3D way. So the next part is the demo presentation about SuperMap functions for 2D and 3D information. Okay. So first, you will need to create a data source which consists of the information such as coordinate system, the default data set of the cadastral plugin environment. So in these tools, you will need to set parameters, include coordinate systems, target workspace names, and the drawing info for the files. Drawing info file is the cadastral database, which is specifically owned by the internal users, in this case, the cadastral agency. You will find the resulting data source in the workspace manager, and these data sources are shown in the vector manager and the map manager. So we'll import the drawings, and you can see the drawings that have been imported into iDesktop. So next, so here we will clip the drawing based on the floor name. In this case, we will clip on the first floor, second floor, and the roof. So here we are drawing clip regions. So we drew boundaries for each floor in the drawing. So after that, we'll be using the batch clip tools to generate image datasets after clipping. So now we are making scale corrections to make it in the correct scale as informed by the drawing layout. So we use the diagonal line. So this is the new data set that is generated after the scaling. So now we are doing georeferencing or registration. So we draw 4 points and a minimum of 4 points for each floor. So after we draw 4 points, we choose batch registration. So we choose the whole floor set from the first floor to the roof and then process. This process will georeference and scale the whole drawing and put them in the same location. So after this process, we'll start to draw the building object. So in this default application, you can draw the room, the door, the outer contour, the walls, the roof, and the borders. So first we change the floor name, and now we are starting to draw the room. So you may use the rectangular tool or the arbitrary polygon tool to do this. So now we can also draw the outer contour of the floor. But don't forget to pick the object and floor name first before drawing. And next we can draw the doors. So after that, you can draw the wall. But we have other tools such as the wall clip to draw the wall automatically instead of drawing it manually. So the wall data set will be the result of this process. So after the first floor is finished, we proceed to the second floor. We can draw it again, or we can also use copy floor. Will object at first. So here we are showing the 2D and 3D integration. Okay, so at the very beginning, we didn't set geographic locations for this vector drawing. So we have reference data of where the objects are located, and we can choose the drawing location registration tool. So now we are again picking 4 points for registration to geo-reference the drawing. So after picking 4 points, we calculate the error and then proceed to the registration process. So after the object dataset has been geo-referenced, you can directly display it in 2D and 3D linkage. You can use the function and we can see the result. So you can also convert the dataset as a model. So for example, you can create a roof model dataset, and we can set the degrees for the roof, the floor heights. So we can make a more detailed and more accurate model. So there. Thank you for watching the presentation.
Thank you, Ian. So Ian has just shared with us the overview and demonstration of SuperMap solutions for the real estate industry. There we have it. Our speakers just gave us a comprehensive introduction to SuperMap's 2D and 3D GIS in the real estate industry. We hope that by this time, it is bringing you some new ideas on your current projects, research, or business. While the presentations were ongoing, our technical team has actually answered your questions already. But in case you would like to ask more, feel free to send us a message. We hope that this webinar has sparked your curiosity about SuperMap, because we are actually happy to announce that we will be offering a free trial license to our participants here. Just send us a message or an email, as you can see on this slide. To cap off our event for today, let us hear some closing remarks from Engineer Ruby P. Rosal, instructor from the GA Department of the College of Engineering and Architecture.
This global pandemic tested the limit of human interactions, but pushes the boundaries of global cooperation to another level, thus creating a huge demand for technological innovations from the different fields, such as in the environment, economics, and politics. The human mind is a dynamic machine. When it is hindered by some circumstances, It will always find ways to achieve the same goal despite having different solutions. People have learned to appreciate biotechnology. A lot of people have appreciated working from home. A lot of people have been able to appreciate using AI in tracking an infected person or in dispersal of the virus. A lot have also been using the GIS spatial tools to monitor the spread of the virus and the efficacy of the state lockdown. They say that technological advancement can be both an ally or an enemy. We rather choose it to become an ally. In the Philippines, there's a huge demand for this, from the academe, the business, the government, and the private sector. There are a lot of emerging startups and technological tools that were found to be relevant these days. In the Philippine real estate industry, 3D modeling is still in its infancy. But what can it really do? Well, it can provide a science-based policymaking in urban development, both in the new constructions and in the rehabilitations of dilapidated infrastructures of old growth centers. It can also enhance visualization in disaster risk modeling and simulation. It can augment real estate tax. It can monitor appropriate development at the respective zoning classifications, and a whole lot more. We are glad that we have been provided with a lot of tool options to utilize and to achieve this. And what is the better way to start this real estate market revolution? It should be in the academe. We hope that the participants have grasped concepts that can help them shape the career path and what they can contribute to our digital society. Till then,
Thank you, Engineer B, and thank you, everyone. We highly appreciate your attendance today. Feel free to visit the SuperMap website to get more information about the company. We also invite you to follow SuperMap GIS on Facebook, Twitter, and LinkedIn because we are constantly posting about the latest GIS trends and what SuperMap is currently up to. For the students here, again, we are inviting you to join SuperMap's first ever local GIS contest in the country, the GISAN. You might also be interested to become one of our university ambassadors. You will become part of the SuperMap team, wherein you will represent your university. More benefits are indicated on our Facebook page, so make sure to like and follow SuperMap Philippines. Again, thank you for attending this webinar, everyone. Don't forget to answer the evaluation form, which you can find in the chat box, so we can bring you a more improved webinar experience next time. Expect your certificates in a few days via email. SuperMap will hold more webinars on more topics soon, so we hope to collaborate with more universities here in the Philippines. We will virtually see you soon in the next webinar or events. For now, goodbye and have a great week.